So imagine a disaster relief situation where a tsunami or an earthquake has changed the environment. It's changed the land mass, it's changed what's underwater, roads are now rivers, and you're first responders trying to respond to that. Your world has changed, your map has changed. So now imagine an autonomous system, a boat for example, that can approach the area and send a quadcopter forward to take new imagery, to update that map, update that world, to inform first responders as they try and bring aid. Northstar can support all of those things. It can be the world that the first responders are using to map through. It can control the quadcopter, it can control the boat. And it's that ability to react to dynamic and changing environments that becomes key in lots of these use cases that we see for autonomy as we move forward. Imagine historically trying to survey the Arctic. That involves large ships, icebreakers, months of planning, months of preparation to deliver a small mapped area. Now we're using autonomous boats with autonomous gliders to run for long endurance missions, months at sea, collecting a huge range of data. And they're collecting that data not just spatially but temporally, so you can see the change by persisting in an environment. These things just weren't possible before autonomy. Another example is Optimizer. This is our decision support aid for maintenance planning, currently targeted at the offshore renewable energy industry, where maintenance planners are having to consider a huge range of factors. So corrective maintenance, preventative maintenance, key performance indicators, what staff they have available and the skill sets they've got, what vessels they've got available to transfer those staff, what's the weather doing. This becomes a very large decision space to try and make decisions in. So we create that decision space inside Northstar and we use our algorithms to walk through that and help provide some support to those plans. We have other uses of Northstar that are not such physical world based. So still a digital world. It's a decision space. We have a system called Tide, which is Team Information Decision Engine, which uses some of the same tools, but is searching a decision space around intelligence. It's designed for intelligence analysts, monitoring their use of information and helping them optimize to find the right information to help further their investigation. We're seeing autonomy used in more and more places. And over the last few years, we've seen autonomy move beyond simple moving from A to B. And we're starting to use these platforms to solve different problems in different and more extreme environments. And those environments force you to have a system that is more capable of reacting in real time to those changing conditions. And that's really what Northstar brings. So we don't simply path and present, we're constantly running to react to the changes in the environment and ensure that you remain optimal against that environment and the mission you're trying to carry out. Northstar can steer a boat, a quadcopter, a submarine, and steer all of them at once so they're aware of each other and optimise them together. And this is really the future of autonomy, is this coordination or cooperation between platforms. So if you currently have an autonomous system, we can give you a better path planner. If you do not have an autonomous system, we can retrofit autonomy to your platform and turn your existing fleet of ships, for example, into autonomous platforms. The more we work with different customers and different partners, and the more we see Northstar able to solve their difficult challenges, the more potential we see for Northstar in other areas in the future. And we're very excited to see where this can take us.